testing week. I'm only going to be introducing you because I don't know this stuff very well. So I'm going to introduce Mrs. Hartwig. But first, I just want to point out what this whole chapter is about and why you're seeing so much of a rat. This is going to be a whole chapter all about rational expressions. And we are going to talk about 9-1 today, simplifying rational expressions. So I'm going to turn it over to Miss Hartwig, and here we go. Okay, let's see. We're going to talk about simplifying rational expressions, and the first thing I want to do is make sure we review a few things about rational expressions. If you remember, 12 over 4 can be written in terms of factors of 4 times 3 all over 4. And because they're written as factors, 4 over 4 is equal to 1. When we reduce the 4s, the reason we can reduce them is because 1 over 1 is equal to 1 times the 3, and you get a 3. And we all know that 12 over 4 is 3, so this works. Yay! Now, it might seem really elementary, but this is really a critical mistake that people make, is that when we have multiplication, it's okay to reduce. But when we have addition, then what we're talking about is adding terms. They are not factors. Now 2 times 3, those are factors, but them together make a term. Plus 2 plus 4 would add up to 12. All over 4, if I try to reduce this, and I were to come in here, which is totally illegal to do, and I tried to cancel those 4s, I would still have 2 times 3 is 6 plus the 2 over 1 now, which would end up being 8. 8 over 1? Well, we know that 6 plus 2 over 1 is 8 over 1, but that is nowhere equal to 3. That is why we cannot reduce terms. So if you see a plus sign, this is bad. This is not true. What we're looking for is multiplication. Multiplication of factors, if you have a factor over a common factor, they reduce to a value of 1. So, for simplifying rational expressions, what is a rational expression? Well, any rational expression is where we have a p of x over a q of x. It can be a polynomial over a polynomial, or in this case, we're going to start with a monomial over a monomial. But those monomials are both going to have multiple factors within them. The first example I want to do with you is just this basic example. If you look, we have 6 times c over 5 times a d to the 4th. That whole expression times 15 times a times d to the 2nd all over 8 times a. You can see all it's multiplying and dividing. You don't see any plus signs or minus signs in here at all. So we have a right to reduce. Now as we reduce this, I would recommend that you also write your solution as you go. It's easy when these get pretty big to lose track of different factors. So I can reduce. If I look at this, I could say, well, I can see that a 5 and a 15 would reduce with a 3 on top and a 1 on the bottom. I can see that 8 and 6 share a common factor of 2. So 6 and 8 reduce a factor of 2, which leaves a 3 and a 4. I just left a factor of 3 on top. Down below I have a factor of 4 and the 1, which I'm not going to write. What else can we reduce? Well, there's factors here. There's a common factor of an a over a. Because it's all multiplying, I can reduce those values. Notice I'm saying reduce. I'm not saying anything else. It's reducing or simplifying. D to the 4th and d squared. D to the 4th. I can reduce d to the 4th with d squared. But 2 of these are going to come out with 2 of those, leaving 2 d's down here, d squared. If I go ahead and multiply this out, I end up with a 9. Multiplying through the top, I get a 9 on the top. Oh, I forgot a factor. See, it's important to not lose those guys. There would be a 9c on top and a 4d squared on the bottom. That's example 1. All factors. Sometimes you're going to get an example like example 2. It still is all multiplication in the first expression, and there's multiplication in the second expression. But the two expressions are tied together by a division sign. What we need to do is take the division and reciprocate the second factor. Dividing by this is the same as multiplying by the reciprocal. We're using inverse functions, which is what we just finished. So what are we going to get? Well, now we're ready to start simplifying this just as the last one. There's a common factor of 3 between the 21 and the 3. I leave a 1 up there and a 7 down here. I'm going to write it down here so I don't lose it. Oh, wait a minute. I'm going to back that up because I just noticed this 7 also will reduce with the 14, leaving a 2 upstairs. So the 21 reduced with the 3 and the 14, leaving a 2, and now I have a 1. I am going to write that 2 up here. I have a 5 down here. That's not going to reduce with anything, so I can write a 5 down here. Let's look at the x's. I have 1 x on top and 2 on the bottom, so 1 with 1 leaves 1 x downstairs. How about the y to the 4th? Well, there's a y to the 4th and no other y's, so y to the 4th will stay upstairs. T, I have 1 t in the denominator and 3 in the numerator here, so I'm going to take one of these t's with one of those, leaving 2 t's in the numerator. All that's left is m to the 5th and m to the 4th. 4 of these m's over 4 of these m's will leave 1 m downstairs. So what we end up with is a 2t squared y to the 4th divided by 5mx. We like to write in alphabetical order, but it doesn't matter. We have a simplified rational expression. It's good to take a second look, make sure you didn't miss anything.